This video will focus on the learning targets. I can define specific heat capacity, and then I can also recognize how mass-specific heat capacity and temperature change affect the energy of a system. So this will actually cover two topics just because they're so interwoven. So when it comes to quantifying the heat change of a chemical process, one type of chemical process you can look at is just when the temperature changes. So in order to quantify how much heat was taken in or came out in a chemical process when the temperature changes, we need to know three things about the substance. One thing you need to know about a substance that's a new concept is something called the specific heat capacity. And what the specific heat capacity is the amount of energy needed to take 1 gram of the substance specified and raise it 1 degree Celsius. Every substance has its own specific heat capacity, and that has to do with its chemical structure and the force of attraction it has on adjacent particles that are like itself. If you think about it, in order to take 1 gram of anything and make it 1 degree hotter, essentially you have to increase its motion. In order to increase its motion, you have to consider how it's relating to other things around it, how massive it is, things like that. And you experience in your world the fact that things have different specific heat capacities. If you think about a nice, beautiful, sunny day in the summer, and you consider that sun shining down on like the metal pole going into the pool, as well as the water itself, from start of day to end of day, you'll notice that the metal pole has gotten very hot from the sun, maybe too hot to even touch. Or you can think about like the pavement around the pool. Yet the pool itself has barely changed temperature. And that has to do with the specific heat capacity. Metal and the pavement around the pool both have what we would consider a lower specific heat capacity. So you need less energy to take 1 gram of that substance and make it 1 degree hotter. Here you have a list of just random things in terms of substances that we can look at their specific heat capacity. And on your thermochemical reference table, you have a whole list of different specific heat capacities. So you see most metals are pretty low, so that means that they easily and quickly heat up, but it also means that they easily and quickly cool down. If you look down at the bottom, we have water, and I do give you water in all 3 states of matter. That's because the specific heat capacity is state dependent. So most of the time what I say is on your thermochemical reference table, the specific heat capacity is based on room state condition. So that one for aluminum, that's solid aluminum, right? That one for mercury, that's liquid mercury. Because water is so common and we use it for phase changes, I give you all 3. If you look at water as comparison to the other one, you can see just how big its specific heat capacity is. What that means is water is very resistant to temp changes. We can put a lot of energy into water and its temperature doesn't really change. Vice versa, we can then use water to cool a lot of things down and water's temperature won't be very affected. It's partially why we use it to cook, because per gram per degree, water has so much energy. You can see on here the thing that's even bigger than water is hydrogen. This is one of the reasons we think about using it for fuel, just per gram per degree how much energy hydrogen has. The other 2 variables that affect the heat when there's a temperature change is how much of that sample you have, so its mass, and then also how big the temperature change was. So when we think about heat coming off, it's how much of that sample we have. The more sample we have, the more heat that could be produced or taken in. It's the change in temp. So if we change the temperature by a lot, that's a big heat change, where just a little temperature change is not a big heat change. And then C is that specific heat capacity, which is, again, the amount of energy per gram per degree any substance has. This equation is only used when temp changes. We usually call it Q equals MCAT because you can see how that delta T works. Delta T is the final temperature that the substance became minus the initial temperature it was to begin with before the temp change. And it always has to be in that order because that will give you the sign, right? If the temp change is one that ends up being negative, I started out hotter and got colder, that would be final minus initial would end up with a negative temperature, which would then end up with a negative Q. So Q again is heat energy measured in joules in this case because C is in joules. That's it for this video. Have a nice night.